So in this video, let's continue the Dodge game. What I want to accomplish specifically in this video is to start spawning our obstacles. In this case, I'm going to spawn a coin and an enemy. If the player touches a coin, they're going to get a point, and the game is going to get harder. I'm going to make objects spawn even faster. If they hit an enemy, they lose the game instantly. The player will be deleted, and we're going to stop objects from spawning. This video will just get them spawning, we'll get the player interacting with them, and then in the next part, we will add UI to it so the game makes sense for our players. They can see their score. When you guys add health, they can see the player health. And when the game is over, we can pop open a game over screen. So to start, because we're going to be spawning coins and enemies, let's make prefabs out of them so we can spawn those prefabs. I have this coin PNG I found on the internet. I'm going to use that. Make sure again, texture type sprite. This one's a single sprite, and I'm just going to drag it onto the screen. I'm going to go inside the enemies sprite folder that I have here. I will use this saw. Again, sprite, single. I'm just going to drag it onto the screen. I'm going to rename them, so the enemy is going to be called enemy, and I think coin can just stay as coin. This coin is very big, so I'm just going to scale it to kind of match the saw. We'll just reset these to 0, 0, 0. Not super necessary, just a force of habit. And let's make them into prefabs. So I will make a new folder, and I'll call it prefabs. Before I even toss these in here, I'm just going to give them a collider, because I know we're going to need one. I'll search up collider, and you could give it a mesh collider 2D. I'm just going to give it a box collider. Same thing with this. I'm going to give it a box collider. Make sure we give it a box collider 2D. Looks like my player doesn't have one, so I'm just going to give my player a polygon 2D collider, and this collider makes it so it kind of matches the shape of our player. You can do the same with the coin and enemy if you want, but I think a box should be just fine. Honestly, actually better than a box. We should use a circle collider, because that matches the shape of them much better. Okay, go into our prefabs, and then I'm just going to drag in enemy, and I'm going to drag in coin. We can see that under the preview, I can see the enemy, and I can see the coin. If I drag these prefabs into the level, you can see that they're the same. And what we're really going to be doing is we're going to be spawning these prefabs over time. Okay, I'm going to make a new game object. I'll call it object spawner. And this is going to be responsible for spawning the objects. We'll just set it to 0, 0, 0 for now. And let's go ahead and make a script for it. So in my scripts folder, I'm going to create a new monobehavior script, and I will call it object spawner. Double click it and just wait for it to open up. And so now with the script open up, first thing I like to do is just create some variables that I know I'm going to need. I know that we need a reference to those two prefabs, right? So we can make a serialize field game object, because that's what the prefab is. It's just a game object. I'm going to have one, I'll call it coin prefab. And I'm going to make another one, serialize field game object. And we will call this one knife prefab. Next, when we spawn these objects, they're going to have to spawn within like the screen's limit. If you guys did want to use the exact same technique that we did with, the camera, or I'm sorry, the background and the player to kind of clamp them to the camera, you can. I'm just going to do something simpler for this one. I'm just going to have a spawn range. So I'm going to make a serialized field. I will make it a float, and I will call it spawn range. Again, I'm making a serialized field, so it's easier for us to kind of test later on, right? It's easier for us to see if this is working or not. I don't know what a good range is. I'll just give it 8, maybe 7 to start. And then before we continue, let's just go back into our level and just assign the script so we don't forget about it. So object spawner. You can see it takes in a coin prefab and knife prefab. So let's drag those prefabs in. I don't know why I called it knife prefab. I should call it enemy prefab. So let me just change that. And just redrag these things in. So enemy prefab and the coin prefab. And then next, just a little trick we can do. We have the spawn range right now, and we can type things in, right? But I know a few things. I know I want my spawn range, for example, to be positive. I don't want it to go to like -7. I just want it to be something from like 1 to, some big number. But I also know that, I don't want it to be something like 600,000 or 60,000 because that's too big. So if we go back to our script, just like we have serialized field, just like we have this attribute here, there's another attribute. In fact, there's a ton of attributes that Unity has, but there's another attribute called range. And remember, the attribute affects whatever the next variable is. So if I type this attribute above spawn range, it's going to apply to just spawn range. So we use the attribute range, and it takes in 2 parameters, a minimum and a maximum. So in this case, I could say something like the minimum is 1, the maximum is 50. If I come back here, and we click on object spawner, now you can see the spawn range has turned into a slider. So it's just a very kind of like small convenient thing, especially, when you're again working with like level designers and like people putting your level together, you're just making the scripts. If you want your value to be within a certain range, and the slider kind of makes it nice, right? There's again a lot of attributes in Unity to kind of organize your scripts. This is just one of them that I thought would be like useful right now. And next, I want to have 2 variables, just before I continue, to kind of control the spawn timing. I don't want our objects to all spawn at the same time, so like I don't want them to spawn, every object to spawn 1 second apart. We want a little bit of variation. So I'm going to have 2 variables to control that. I will have a minimum spawn time and give it some kind of value like we'll start with 2. And I'm going to have a max spawn time and give it again some other value like 4. So really, when my object spawns, it should spawn somewhere between 2 and 4 seconds, and this is something we can edit later on. So to think about the logic here, as long as our player is alive, I want to, every 2 to 4 seconds, spawn either a coin or an enemy. So every 2 to 4 seconds, we want some way to pick between the coin and the enemy. I'm going to have it pick 50-50, so it's going to be an exact, like, it could be 50% chance of it being a coin, 50% chance of it being a prefab. Our script is going to have to wait somehow between 2 and 4 seconds, and then redo that again. If you guys have used Unreal before, there's this node in Unreal called delay, which lets you pause execution of a script. Unity doesn't quite have something like that. We can't just in our update use a delay function. That doesn't quite exist in Unity. Instead, in Unity, we have the concept of a special type of function called a coroutine. You will, when you start looking up online tutorials, people use coroutines a lot. A coroutine, all it is a function that can pause its execution and then come back to it after like a certain amount of time. So in our case, we want our function to be looping. It's going to spawn an object. It's going to pause its execution for somewhere between 2 and 4 seconds, and then it's going to run again. To use a coroutine or to make a coroutine, we don't use the keyword, we use the keyword IEnumerator. And then just like a function, we give it a name. So I'll call it spawn. This IEnumerator references the return type of this variable, and we will be returning essentially an amount of time for this function to wait before it runs again. So in this case, to start, I want to anytime the player is alive, I want to run this function, right? So while I don't really have any logic for the player alive, so right now I'm just going to say while true, and what that means is this while loop is just going to keep running. It will never stop. So while true, let's make a new game object. We'll call it prefab to spawn. So this is going to be holding the value of the current prefab we want to spawn. And now we need to pick, are we going to spawn the coin or the enemy? So we can say if random dot value, and all random dot value does is it gives us a random value. If we can read the tooltip, it says returns a random float between 0 and 1. So really, if random value we can say is greater than 0.5, let's just say we want to say prefab to spawn is going to be the coin. Otherwise, prefab to spawn will be enemy prefab. So when we run this, it's just going to pick, it's just going to generate a random value. If that value happens to be over 0.5, so 50%, it's a coin. Other 50%, it's an enemy. Now we need to determine where we're going to spawn this, right? So really the Y and the Z are going to be pretty obvious. The Z is going to be whatever Z the player is on. So we're at the same plane. The Y is just going to be wherever we place the spawner because that's where we're going to start from. And the X is what matters, right? This spawn range, this controls how much X we're going to spawn on. So we will make, let's calculate that first. We'll do float X. It's going to be equal to, and I want it to spawn somewhere between the range of minus spawn range to plus spawn range. So in this case, it's going to be from -7 to +7. And again, we can use that random class. We can say random dot range, and random range takes two numbers, a minimum, a maximum, and it just gives us a random number between them. So in this case, I want to generate a random number from minus spawn range to spawn range. Let's put it all together in like a little vector3, so we can just pass that along. I'll call this vector3 spawn position, and it's just going to be a new vector3 where the X is going to be this X variable we made here. The Y is going to be the transform position dot Y, and then the Z is going to be -1 because I put my player on the -1 and the Z, so they were in front of the background. Finally, we need to spawn the actual game object, right? To do that, we use a function called instantiate. There are many different ways, many different types of parameters this instantiate can take. There's many different overloads for it, so there's many different ways of using it. The way I'm going to be using it is to pass in which game object we want to spawn, so which prefab we want to spawn, what its transform is, like what its position is, and then what is its rotation. So in this case, the game object to spawn is going to be prefab to spawn. What is its position? Well, it's going to be spawn pose. And then what is its rotation? It doesn't really matter. Its rotation is going to be 0, 0, 0. And to get that, there is a special variable called quaternion.identity. This is called the identity rotation. It's essentially just 0, 0, 0. And after all this, so we've done our logic, we need to tell Unity, hey, continue running the rest of the game, wait for a certain amount of time, and then come back to me, and I'm going to run again. To do that, we type in yield return. See, we're returning a value, right? What are we returning? We're returning a special value that's going to be called wait for seconds. And this takes in an amount of seconds to wait. So if I typed in 4 here, that is going to take in 4 seconds. But I don't want to give it a fixed value. Instead, I'm just inside here going to use random.range and say I want it to be somewhere between the minimum spawn time and the maximum spawn time. Max spawn time. There you go. Okay. So we have our function working. We just need to really call it once in start, because once this function runs once, it's going to keep running because this while loop, we've just set it to true for now, so it's never going to stop. We can't call a coroutine like we would call any other function, so I can't just type in spawn. It will work, but it's not going to run as a coroutine. Instead, we need to pass this function into another function called start coroutine. Start coroutine just takes a function, a coroutine function specifically, and it starts it. So in this case, I'm going to say spawn. Okay, so now if this all worked just fine, when I hit start, we have our object spawner in the middle of the screen. We should just start seeing our objects randomly spawn along that -7 to 7 on the X in our scene. So let's hit play. And we can see that it happens to be spawning. And there you go, it spawned a coin as well, so we know that's working. Okay, awesome. So that's kind of one part dealt with, right? We have a object spawner that spawns our objects, it spawns them randomly in kind of a range. The next little bit is all these objects, both the enemy and the coin, are going to be moving downwards. They have to be falling. So we'll make a script for that. I'll create a new script, call it falling object, because that's what they're going to do. And before we even write the script, let's attach it to our game objects. So we're going to go into prefabs, and then I can double click on these prefabs, or you could just single click to open up the inspector here. I'm just going to add a component, and it's going to be the falling object component. Same thing with the enemy. Make sure we add the falling object component. We'll open up the script. And the script should hopefully be pretty similar. Simple. All I really want is for when the object spawns, it's just going to like start. It's just going to keep going downwards. When the Y value passes some negative value, we're just going to destroy it. Again, you could use the same trick we used like last time to determine what the height is and then have it destroy, so that changes according to the screen size. I'm going to keep it simpler here. I'm just going to say that if our thing crosses something like -5 or -6, it's going to be destroyed. So we'll go back to our script. And let's start by making the variables we need. So I'm going to make a float, call it destroy y, and I'll set it to -6. I could make this variable a serialized field, but hopefully this -6 is going to be something where I just set it and forget it. It's not going to be, it's not a variable that's going to really control the gameplay field. So there's no reason for us to make it a serialized field and have it be something controlled. This is something you just kind of test a few times. Once you find a good value, we set it and forget it. So just like our spawn time, I don't want to have the objects all spawning at the falling at the same speed, right? We want a little bit of variation with that. So I'm going to make a serialized field, just like we did with the spawn time. I'll call it min fall speed. We'll set it to something like 2. Oh, I forgot to give it a type. It's going to be a float. And then make another serialized field, which is going to be a float. We'll call it max fall speed. And set it to something like 5. And finally, I just want a float to hold the current fall speed of this falling object. Every falling object is going to have its own fall speed. This minimum and maximum is just going to be used in the beginning to determine what that number is going to be. So I'm going to make a variable called fall speed. So when we start the game, because each object, when it spawns, is going to determine its fall speed, we can say fall speed is equal to random.range. What is the minimum? Well, it's min fall speed. What is the maximum? It's max fall speed. And then on every frame, we just want to move this object down. So we can say transform dot translate. Which direction do we want to move it? Well, I know I want to move it downward, so that's vector3 dot down. What speed do I want to move it at? Well, fall speed. And finally, whenever we move things on in our, in a game, if we were just to think about it, this update is going to run at a different speed for every kind of computer, every person running it, right? My computer might be really bad. It might only be able to run my game at 30 frames a second, which means this update is only going to be running 30 times a second. If your computer is really good, it's running at 60, 120. This update is going to be running more often. And what that means is if I have a slower computer, this update runs less. The objects move slower because this is running fewer times a second, right? This is going to only move 30 times in that second. Whereas if you're running at 60 FPS, this update is going to run 60 times, which means this transform.translate, the object is going to move 60 times that second. And that means that your object is going to move twice as fast as my object because this movement is being called twice as more. So this ends up locking our movement, locking what's happening on screen, tying it to the frame rate. And that's not good programming. Again, that's not going to make for a good game, right? You might find there's a lot of older games that tended to have this issue. And what they did, the way they fixed it, was just to lock the frame rate. You could not play this game above 60 FPS. You couldn't play this game above 30 FPS. If you found a way to unlock the frame rate, then your entire game will not run correctly. And so to avoid this problem, what we do is we multiply whatever we're moving by the amount of time that it took to render the frame. In this case, there's a special variable for that called time.delta time. And what this does is it scales this value. So it doesn't matter what our frame rate is. We're only going to move a little bit that frame depending on how long it took us to render that frame. I know that explanation is probably a little bit confusing without some visuals to go along with it, but just know anytime in update specifically, when we move things around, we want to scale it by this time.delta time. Okay, so on update, we're going to move our thing downwards by fall speed and then multiply it by time.delta time. If our game object, so ever crosses that y threshold, so if ever our transform dot position dot y is less than our destroy y, so if it ever goes below this -6, then just destroy. There's a function called destroy. We want to destroy game object. Game object with the lower g refers to this game object, whatever this falling object's attached to. So let's just check that out. We have already attached our scripts to our prefab, so this should just work. I'm going to hit play. And you can see they're spawning and they're falling. Now that we have this working, it might be a good idea to just move our spawner to, the top of the level so we can see that happening properly. You can see they're spawning as they go through the end. If we look at both the scene view and we can see it in the hierarchy, it's spawning, it goes below that threshold, and then it's gone, it destroys. So that way we don't keep these objects forever, like in our hierarchy. They get destroyed when they go past the end of the screen. Okay, and now there's only one last little bit to deal with, which is it actually interacting with the player. So to start, we need to do two small things. One, our player needs to differentiate between the enemy and the coin. So just like we had done with the previous project, we can use tags for that. I'm just going to open up prefab, click on the coin. Right now it's untagged. I'm going to add a tag. I'm going to add two new tags actually. I'll add one called coin, and I'll add another tag called enemy. This way, when something collides with the player, they know, was it the enemy or was it the coin? Go back to prefabs, click coin, make sure we tag it as coin. Enemy, make sure we tag it as enemy. And now The other thing we need, uh, whenever a collision happens in Unity, you need two things. You need a collider, both objects need a collider, and one of the objects needs a rigid body. Even if we're not going to be using like physics, it doesn't matter. One object needs to have the rigid body. So rather than giving the coin and the enemies, like so we spawn a bunch of objects with the rigid bodies, I'm just going to give it to the player. So I'm going to add a component to the player and call it rigid body 2D. However, I don't want this rigid body to actually be doing any physics, right? I don't want this right now. The gravity scale is 1. I don't want it to fall with gravity. I don't want when it collides with things for it to bounce and move around. It's a more static game than that, right? We're not doing physics calculations. So we can change the body type of this rigid body 2D. Right now it's set to dynamic. Dynamic is the kind of rigid body that responds to all these forces. We can change that to kinematic. Kinematic is a body that can move around, but it doesn't really respond or act on any of these forces. So this way I can have my rigid body here, don't have to worry about any of the physics calculations, and instead we're just using it for that collision detection. The last thing I'm going to do before we start writing like the little collision script is in our coin and enemy we have the circle collider. In our previous project, we used a function called onCollisionEnter, right? So there's two types of collisions actually, though you can have in Unity. One is an onCollisionEnter, and the other is a trigger. A collision enter is one where two objects collide, and one of the big parts of it is Unity tries to decollide them, as in on a certain frame, these two collisions overlap, they like intersect each other, and Unity tries to push them away. That is like that onCollisionEnter collision. There's a much simpler version of that called trigger. That's essentially just these two objects collide. We don't need to push them out of each other. They don't really interact, but we can detect if they're overlapping. If they ever if they ever intersect with each other, we can detect that, but there's nothing to be done about it. We just know that they've overlapped. And this is the idea of a trigger. We see triggers, all throughout games. If maybe like an inventory item or an item that you can pick up, when we go close to it, you see a little icon pop up saying press E to pick up. Those usually use simple triggers where around the object to pick up, there's a small trigger box. When the player enters that, E pops up. When the player leaves that, E goes away. And that's all we need for this game, right? When the player and the coin or the enemy intersect, that trigger event happened, we can either give them some points or we can kill the player. So make sure we make both of these triggers. And then let's go back into our player script where we are going to handle the collision. So last time we used a function called void onCollisionEnter. Now we're going to use one called onTriggerEnter. Again, there's two different variations, one for 3D, one for 2D. We're doing everything with 2D, right? Our rigid body is 2D, all our colliders are 2D, so we're going to use onTriggerEnter 2D. onTriggerEnter 2D. It takes in a parameter that's a collider 2D called collision. You can call it whatever you want. This is what it names it by default. And for now, we'll just start off by checking if the collision dot game object dot compare tag, if it's enemy, then we just want to destroy the collision dot game object. We just want to destroy that game object. And really that's the same thing for the coin right now, just while we test out our collisions. So if our collision dot game object dot compare tag with the coin, we just want to destroy the coin. Let's check if that worked. You hit play. And it looks like my player is just locked for moving too far. But we can see I touched that coin. It got destroyed. Let me just turn down my object spawn range for now. Okay, when I touch the enemy, it gets destroyed. When I touch the coin, it also gets destroyed. Perfect. So that part works great now. So we have the things spawning, they're falling down, everything can collide with each other. The last little bit that we're going to deal with in this video is just a little bit of logic of what happens when we collide. So when we collide with the enemy, I want the game to be over per se. And that's going to be two things. We're going to destroy the enemy. We're also going to destroy ourselves. So, the player isn't around anymore. And finally, I want things to stop spawning. So to do that, our object spawner is the one that spawns objects. Let us get a reference to the object spawner in the player. We'll make a serialized field. I want to get a reference to this object spawner script. So the type of variable I want to reference is going to be object spawner. And I'll just call it object spawner with a lowercase o. And in our object spawner, instead of just using this while true, I'm going to make a new public boolean. I'll call it can spawn, and we'll just set it to true to start. Instead of while true, I'll say while can spawn. And finally, in our player controller, this stop spawning, I could just say object spawner dot can spawn equals false. Next, let's deal with the coin itself. I want to destroy the coin. I want to add score. And then finally, I also want to increase difficulty. So we will deal with the adding score, in the next part, just when we start working on the UI. But adding the score here is super simple. We'll just push that off to, connect it with the UI when we work on that. Let's deal with the increasing difficulty. There are many ways that we can increase difficulty here. You can work on reducing the spawn time. You could reduce the time of, you could increase the speed of the objects that are falling. There's many ways, we could deal with that. We could have more objects spawn. We could make them spawn faster. We could spawn different types of objects if we had them, but in this case, we only have two. Maybe you could increase the size of the enemies while reducing the size of the coins, So there's many ways you can deal with difficulty. In my case, I'm just going to reduce this minimum and maximum spawn time. So for the can spawn, we made it public. Technically, we could make these public as well. But I'm going to deal with a slightly different kind of way of doing that, where we want to keep these private, but we want to be able to change them. And to do that, we just make helper functions. So I'm going to make a new public helper function. I will call it get spawn. We'll make two of them. I'll call it one get max spawn time. This function is going to return a float. And all it's going to do is just return the max spawn time. I'm going to make an exact copy of that for the minimum one. Call it get min spawn time. And it's just going to return the min spawn time. Now I need a way to set these. So what I'm going to do is have another public function. This one isn't going to return anything. It's going to be a void. And these are going to be for setting the variables. So we'll have public void set spawn times. And this is going to take in two parameters, a float new min spawn time and a float new max spawn time. And all we need to do is is to set the max spawn time to the new max spawn time and the min spawn time to the new min spawn time. Now, the reason I made these functions instead of just making these public is unlike this Boolean, which can just be true or false, really be nothing else, these can be a number. And what happens again if someone puts in a minimum spawn time of -3 or a maximum spawn time of -3? Well, that can't, that just can't be the case. We cannot have a negative spawn time. So by making this a function, I can control the setting of it. I can make sure if someone sets it that we don't set it to a negative number. So I could say if max spawn time is if the new max spawn time, whatever they pass in, is greater than 0, only then do I want you to set it. And same thing, if the new min spawn time is greater than 0, only then do I want to be able to set it. And by using the set spawn times rather than making this public, I now have control over that. It's less error prone, right? We can share this code with other people can use my object spawner, and there's less chance of them making an error because they don't need to read and understand my code. They just need to know we use this set spawn time function. So let's go use it in our player controller. If we touch the coin, all we want to do is do object dot, we'll split the code up. So we're going to have float new min spawn time, and that's going to be equal to the object spawner dot get min spawn time, and I'm just going to subtract it by 0.1. So it'll go down by 0.1 of a second. Same thing, we'll make a new max spawn time. Get the new max spawn time, and same thing, just subtract it by 0.1 f. And the nice thing about the way I've dealt with this is we can keep subtracting it, but at some point when this new min spawn time and max spawn time go below 0, our game's not going to get more difficult. That's just like, where it's going to be the most difficult, because our object spawner will not set it to anything below 0. And then finally, object spawner dot set spawn times. It takes the minimum one first, so we're going to say new min spawn time, comma, new max spawn time. Okay, and let's check if those worked. Let's hit play. We have the object spawner selected. You can see the minimum and maximum spawn time are 2 and 4. Let's just start by hitting this. I have made a small mistake. I have forgot to set in my player controller, the object spawner. I have forgot to set it. So this has given me an error that says null reference exception, object reference not set to an instance of an object. And if I double click this error, it'll open up and tell me where that error is. The error is happening on line 33 when we say object spawner.can spawn equals false. What this error is saying is we have a reference to an object. In this case, that object is called object spawner, and it's saying it's set to null, but it's expecting it to be set to something. And if I look here, it's set to none. That's the same as null. So when I call it, when I'm like, hey, object spawner, stop spawning, my script doesn't know what object spawner exactly is. It knows that there is a variable called object spawner, but it's not set to anything. So when it asks it to do something, there's no one receiving it. So we make sure to set it. Let's hit play and try it. And there you go. That destroys our player. Let's try the other one. Let's try the coin. In fact, let me just pause it, make sure object spawner is selected. And now you can see as we collect the coins, that minimum and maximum spawn time are both coming down, which means objects are going to spawn more often. If you guys would like a slight challenge when you're working on this, instead of trying to change the minimum and maximum spawn time, try and figure out how you can get the objects to all move faster. How can you make it so that when the object spawner spawns new objects, it spawns them and it can control what the minimum and maximum fall speed are. So right after this instantiate, right, it should be able to set that new minimum and maximum fall speed. If you want a slight challenge, try that instead. This is a simple way of kind of doing that. Anyway, That's pretty much it for this part. We have got our objects now spawning, we have the difficulty increasing, and we also have the objects like colliding with the player, so it's interacting with them. In the next and final part, we will deal with the UI, getting our score to show up, getting a game over to show up, and also adding some simple sounds, right? Making it so that when we touch a coin or the enemy, we make some different sounds. I think sounds can really elevate a game. Playing a game that doesn't have any noise is it's not as interesting, and sounds are a very easy way to add oomph to your game and make them just feel more professional. So we'll do that in the next video as well. Anyway, thank you guys for watching.